Alright, on this lesson we're going to try and do what we call composition of functions. Now, composition of functions, think of it like this. We're going to take two functions, okay, we'll call them f of x and g of x. And our goal is to combine them, to put one into the other, right? So the way we're going to look at it is we're going to start with some sort of group of numbers like our x. So after that we are going to perform a function on it, depending on which one we choose. And it's going to go somewhere. It's going to get an answer. Well, that answer then we're going to use again in the other function we didn't use. And that, the entire thing from the beginning to end, is the composition. The way it looks is there's two standard ways it looks. Now, it can be multiple ways. You can use the same letters and things like that. Those looks are f of g of x, or sometimes written f of g of x, like that, or g of f of x, or g of f of x, right? Now, big deal, order makes a huge difference in this, okay? So if I do f of g of x, let's just name a function. F of x, will make it x squared, and g of x is 2x plus 1. If I want to take a look at f of g of a number, let's pick my favorite number, 5. We're going to see if we can perform this composition, where it's at f of g of 5. So the first question is, you have to work inside out, or right to left if it's easier to see, but inside out. Because think about it. Order of operations says do what's in parentheses first. Well, do what's in parentheses. I need g of 5. If I go to my g function, what is g of 5? Well, g of 5 is 2 times 5 plus 1, which is 10 plus 1, which is 11. This number is 11, so I can substitute that out. Replace g of 5 with 11. Right? Well, now I need f of 11. Well, f of 11 is you plug 11 into x squared, so it's 11 squared, which is 121. So my final answer is 121. Right? F of g of 5 is 121. Now, what's interesting is if you do it backwards, okay? So let's do g of f of 5. G of f of 5. This time we're going to start with that function on the left, the f of 5. Well, that's 5 squared, which is 25. F of 5. So this is 25. So now I need g of 25. Well, g of 25 is 25 plugged in there. It's 2 times 25 plus 1. That's 50 plus 1, which is 51. All right? So you can see the composition order makes a difference. One was 121. The other one is 51. Okay. Think of it like this. Here's my pictures. What we did with this one right here and the second one, we started with 5, applied f of x, or f of 5, and we got our new number, which was 25. Then we took that one, applied g of x, and got our new answer, which is 51. Okay. And that whole thing is the composition. So we're going to do this in two ways. Right? We're either going to find a formula that represents the composition, or we're going to plug numbers in. All right? So the first one I'm going to do is the inside out value, which is determine the value of the inside function. So you're going to plug in your number, or if it's an x, and then use that new number and apply it to the second one, or the outside function. Right? So we've got a couple examples here. If it lets me go to the next page. There we go. So this one's f of g of 3. And this is how I normally write it. I like to use this. I don't like to use the fog function. I don't have to. Well, g of 3, I look at g of x and I replace it with g of 3. Well, that's 3 minus 2, which is just 1. Well, g of 3 equals 1. So now I can do a replacement. So now I need f of 1. Well, f of 1 is 3 times 1, which is 3. So f of g of 3, it's 3. I'm going to skip over here where it's the same exact number, g of f of 3, but it's backwards. So now I need f of 3. That's 3 times 3, which is 9. I need g of 9 now. And g of 9 is 9 minus 2, which is 7. So you can see these two things are different. Right? I'd like to just plug in, get an answer, and then plug it into the next one. We'll do this one here, f of g of 1/2. G of 1/2 is the start, so it's 1/2 minus 2, which is negative 1.5. Well, now I need f of negative 1.5. Well, I go into my f function on the left. That's 3 times negative 1.5. That's negative 4.5. So this is negative 4.5. I'd like to just swing around and plug them in and go as I see. It seems like an easier method for me. But we also need to be able to determine the function rule. In other words, what is the composition actually doing? Can I do it in one step? Like I showed you the diagram from before at the end. We're doing it, see how I plugged in, got an answer, then I plugged in. Wouldn't it be nice just to go to the right answer? If we had a formula to do it, we're going to try that. So, the second method is follow the rule. Find the rule, and then plug it in. Right? So, I have some g of f of 3, and I have g of f of 1/2. Okay, I'm going to change this one because it makes no sense to have that. I'm going to make it, oh, sorry, I'll keep that one. That one looks fun. But I'm going to change this one to f of g of 3. Right? So if we could determine our f of g of x function, we can then just plug in 3 and see what happens. All right. Well, let's look. F of g of x. So g of f of g of x looks like that. This right here is just that right there. So it's just f of x minus 2. We did that before. Wherever I see it should be 3x, I'm going to replace this x with what's inside, which is 3 times x minus 2, which is 3x minus 6. Notice how it's a function, or it's a formula when we're done. Okay. If we do it the opposite way, look, well, f of x, if we look here, it's 3x, so g of 3x is what we have, really. I did replace f of x with 3x because that's what it says. And now remember, g of x was x minus 2. Wherever an x is, I'm going to replace it with 3x minus 2. And you can see that the composition of g of f of x is different than the one over here, which is f of g of x. What's the bonus part is now if I have these formulas, I can actually compute these without doing the double step. So if I need f of g of 3, f of g of x is this. All I got to do is plug 3 in here. 3 times 3 is 9, minus 6 is 3. Didn't we do that when we followed the rule? Where we followed the thing, we plugged in 3 into one, then we plugged in the other and got the right answer. So you can see it still works. Now I have g of f of 1/2. Oh, I'm going to plug it into here. Well, it's 3 times 1/2 minus 2. Now that's 3/2 minus 2, which is negative 0.5. Right. If I followed the actual thing, what is f of 1/2? Well, f of 1/2 is 3/2. And then g of 3/2 is 3/2 minus 2, which is the same thing. You can see both work. Okay? But we should be able to find the composite function rule, or the rule, and we should be able to interpret values. So we got a couple more here, probably more than we need, but let's get some practice in. F of g of 2. I'm going to follow the plugging in. So I find g of 2. Well, that's 4 times 2, which is 8. Well, then I need f of 8. Now look at my f function. That's 8 plus 5. That's a 5. Sorry, looks like an 8 to me. And that's going to be a total of 13. So this is 13. Well, let's do f of g of negative 1. Well, g of negative 1. That's 4 times negative 1, which is negative 4. I need f of negative 4 then. Negative 4 plus 5 is 1. So my final answer is 1. Switching it up to g of f of 3. Notice how I work inside out. F of 3 is 3 plus 5, which is 8. And then I need g of 8. And 4 times 8 is 8, 16, 24, 32. So you can see what makes a difference. And then I have g of f of negative 2. So f of negative 2 is negative 2 plus 5, which is 3. And then g of that function, which is 4 times 3, which is 12. Okay. So you can see we follow and go. We have more practice here. Unfortunately, I'm missing my formulas, which doesn't really help too much. So make sure when you do these things, look at what you got. So I'm going to split the page so I can see what I got formula-wise. If it lets me, there we go. So I need f of g of negative 5. Well, f of g of negative 5 is the way I look at it. G of negative 5. G is 4 times x. So 4 times negative 5 is negative 20. And now I need f of negative 20, which is negative 20 plus 5, which is negative 15. Okay. I continue onwards, and you can see, just be careful of your functions. F of 3 halves, well, that's 3 halves plus 5, which is just 6 and 0.5, and I need g of 6.5, so that's 4 times 6.5, which is going to be 26. I got the hop function, h of p of negative 3. Well, I need p of negative 3 to start. Well, p is 2x minus 3, so that's negative 6 minus 3, which is negative 9. Now I need h of negative 9. Well, negative 9, the whole quantity squared is 81. Right, and then the pole function. I need h of negative 1. Now that's x squared is h, so negative 1 squared is 1. And then I need p of negative 1. Well, p is 2x minus 3. 2 times 1 is 2, minus 3 is negative 1. Okay, so you can see we can just follow these. The last piece is to look at rules that it can be. Okay, we should be able to construct the rules that they are. Right, so I'm going to do a couple before I run out of time because I'm running out of it. I want to do f or g of h. So g was 4x. G of x is 4x. And h of x was x squared. Oh, good. Alright, I'm going to zoom in on that. So I need g of h of x. H of x is just x squared, so I need g of x squared. Well, g is 4x. Wherever I see an x, I'm going to replace it with x squared. So it's 4x squared. That's my final answer. So that rule takes us in one swope. Okay. Doing it backwards, you're going to see just a slight change. Maybe, or maybe not. So let's take a look. H of g of x, you can substitute g of x out with 4x. I need h of 4x. Well, in this one, wherever I see it, an x, I'm going to replace with 4x. But be careful, put it in parentheses, 4x squared, which is 16x squared. Okay, that composition's a little tougher. I need the p function for the next one. And the p function way back, if I can get to it, if it lets me, is 2x minus 3. p of x is 2x minus 3. Hey, let's go, next page. Well, I need h of p of x. And if we just found that p of x is 2x minus 3, I need h of 2x minus 3. Well, h was x squared, so wherever I see it again, it's x squared. Wherever I see an x, I'm going to replace it with 2x minus 3. And make sure it's in parentheses. So now here you could FOIL it out if you needed to. If you do that, that's 4x squared, let's see, minus 12x plus 9. Okay. Then the last one was f of p of x. Okay. P of x. So do we have p of x? Yes, it is. It's 2x minus 3. So I need f of 2x minus 3. And our f function, well, we kind of lost it from the beginning, is x plus 5. So wherever I see it, it's x plus 5. Wherever I put it, see an x, I'm going to replace it with 2x minus 3. Okay, that was my x, and then there's a plus 5 at the end. So now it's 2x plus 2 is my composition. Okay, so you can see there's many ways to do it. You just got to keep track of what you're doing. Remember, you move right to left, inside out. Okay, you can compose with yourself if you want to. Like if I wanted to do h of x, well, h of x is x squared, and then h of x squared is x squared squared, which is x to the 4th. So you can see there's multiple ways to do it. All right, keep trying, do your best, and I'll see you later.